Lesson 4.2.1. What if I know the hypotenuse? In this lesson, we're going to learn about the sine and cosine ratios. We'll start a triangle graphic organizer. So let's start with the first question here. While traveling around the beautiful city of San Juan, should climb several steep steps. One of the steepest, Filbert Street has a slope angle of 17.5 degrees according to her guidebook. Once Juanisha finishes walking 100 feet up the hill, she decides to figure out how high she has climbed. Juanisha draws a diagram below to represent the situation. So this is the diagram. That's 100 feet. We want to figure out how high she's climbed. We don't know how far she's walked. We know the angle is 17.5. Can a tangent ratio be used to solve for delta y? Why or why not? So a tangent ratio, remember, tangent of an angle is delta y over delta x, which is just opposite, which is the angle opposite. Like this is always my delta y, and then my delta x is next to it. And those are the two values I don't have. So the tangent ratio is not going to help on this one. So I'm bringing you more information. Let's move on for now. To find out how high Juanisha climbed in problem 4, for instance, you need to know more about the relationship between the ratios of sides and of a right triangle and its slope. So you need more information. So they gave us this example here. Use two different strategies to determine delta y for the slope triangle shown in the diagram on the right. So you want to know what delta y is right here and right here. They want us to do two different strategies. So look at this first one here. This is a right triangle. I have no angles. So the way I could solve this is using the Pythagorean theorem, right? A squared b and c. So I could do 1 squared plus b squared equals 2 squared. So 1 plus b squared equals 4 minus 1 minus 1. You get b squared equals 3. Square root of that. B equals radical 3. So that's this one. Now the other one, we have 60 degrees here. We could do a tangent ratio, or we could do a 30-60-90 triangle. So I'm not sure how well we remember 30-60-90 triangles. So here's 60, here's 30. This is x, x rad 3, and 2x. So given this would be 3 rad 3. Given a 30-60-90 triangle. If that's not good, if you don't remember how to do that, we can also just do a tangent ratio. Right? Tan of my angle, 60, equals opposite, which I don't know, over adjacent. Delta y over delta x. So I can cross multiply. 3 tan of 60 equals delta y. Put that in my calculator. 3 times tan of 60. And I get 5.196. So I'll show you now it's the same thing as 3 rad 3. If I do 3 radical 3. Alright, so same answer. So I figured out the missing type both two ways. Since I know angles and it was a right triangle, I just did a squared Pythagorean theorem, a squared b squared equals c squared. C is always the hypotenuse. And the other one I could do 30-60-90 triangles if you remember how to do it. Or just set up a tan ratio. Tan of my angle equals opposite of adjacent. And solve it. Calculate the ratio of delta x over the hypotenuse. So that's this guy over the hypotenuse. So one of them is 1/2. And the other one is 3 out of 6, which is also 1/2. Why must these ratios be the same? Well, if you look at this, we have an HL similarity. We have right angles, and then we have hypotenuse and leg. They're the same ratio. So triangles are similar by HL. Right, because we have two right triangles, and then the hypotenuse and the legs are corresponding. There, the ratios are the same. So, similar triangles. Determine BC and AC in the triangle below. Show all your work. Okay, so we know now. We can do this a couple ways. We know the ratio of that triangle there is 1/2. Right, this is 2 and this is 1. So if I could set proportion, 1 over 2 should equal the same thing as BC over 7. Right, this side over this side should be 1/2. Right, so then we could solve it. I'll cross multiply. 7 equals 2BC. Then divide by 2. So 3.5 equals BC. Like that. So this is 3.5. And now they want me to find the length here. So there's a couple ways to do it. I could do a squared, b squared, c squared if I want to. Or I can set up I can do a tan ratio. So either way is fine. Let's do a squared, b squared, c squared. So a squared, which is 3.5 squared, plus b squared equals 7 squared. I'm going to use my calculator either way. I don't know what 3.5 squared is. Right, and that's going to be 49. 7 squared is 49. I'll put 7 squared here. And then we're going to subtract it. So 749 minus, let's put some stuff down actually. 12.25 plus b squared equals 49. Let's subtract the whole 0.25 from both sides. And we get b squared equals 36.75. And then the square root of that. .06. So AC is about 6.06, like that, right? So that's how I found AC and BC. BC we just went from, since we know the similar, anytime with any degree of the 60 are all similar, so if that's 7, the ratio of leg over the hypotenuse is 1/2. So the ratio of leg over hypotenuse should be the same. And then I did a squared, b squared, c squared on that one. I guess I could have done a ratio of the long side over the hypotenuse, but that's a little weirder. There I go. Okay, now let's go to the real point of this lesson, is that there's new trig ratios. Before we only had 10, we had the ratios, right? We had opposite over adjacent. That was tangent. Now we're going to have some new ones, like first the sine ratio, pronounced sine, like the sign you see on the billboard. So that's called a sine ratio. And that's always going to be, sine of an angle is always going to be opposite over hypotenuse. So if you look at this triangle right here, right, there's my angle. Remember, opposites always want to cross over hypotenuse. So I guess you could say delta y over hypotenuse. Right, so in this case, sine of 6 would be the opposite one, which is rad 3 over hypotenuse 2. So that's sine. Sine is opposite over hypotenuse. Opposite over hypotenuse is what sine is. And there's another one called cosine. Cosine. So like sine, but with a little co in front of it. And that's going to be adjacent over hypotenuse. Adjacent would for sure just write ADJ. Or you know what I think about it is delta x. So this would be adjacent, the one next to your angle, and that's the hypotenuse. So you can think about it as delta x over hypotenuse. So here, right, my adjacent would be 1 over hypotenuse 2. So cosine of 60 is 1 over 2. Like tangent ratio, your calculator can give you these values. So like if I put in my calculator, if I put cosine 60, I should get 1/2, because that's what the ratio is. 0.5, 1/2. Right? If I put cosine of, if I put sine of 60, it says for any 60-degree triangle, this is what the ratio should be. You should get rad 3 over 2, which is 0.886. And I get that. So there are two new ratios. Yeah, calculator is my correct ratio. Yeah. Does it calculate the correct? Yes. Okay. So now we're going to use that to figure this out here. So use the triggers to write an equation and solve for A in the diagram below. So if I was going to solve for this, you want to highlight your angle and then list it out. So the one opposite is always opposite. Like the one across from the angle you're talking about is opposite. The right angle, the one across from the right angle is always your hypotenuse. And then this side here would be your adjacent, the one next to it. Now in this case, I only have a value for opposite, and I have hypotenuse. So I want to find a ratio that has opposite and hypotenuse. If you look up here, cosine is adjacent of hypotenuse, and sine is opposite of hypotenuse. So that's the one we use, because sine is the opposite of hypotenuse. So I'm going to set up a sine of the angle equals opposite over hypotenuse. Just like we do with tan, but now we're going to do with sine. And now we just got to solve it. So how do we solve this? Put over 1, cross multiply. A equals 15 times sine of 23 Also put that into our calculator. So 15 times sine of 2030. We get A equals about 5.86. Anytime I do a round, I always put I don't put straight lines, equal signs, I put little approximation lines, little curly ones. So that's what A is. Let's do one more, make sure we got this. Likewise, write an equation to solve for B in the following triangle. So same idea. Here's my angle. Across from that is opposite always. The one opposite the right angle is hypotenuse. And then this is my adjacent. And in this case, we have the adjacent side. Oops. Right, we have that side, and we have the hypotenuse again. So adjacent hypotenuse is what I'm going to use. That's the only values I have. Like, I don't have anything for opposite. Right, we're not going to use this one. So adjacent hypotenuse, we look at which ratio is that. Adjacent hypotenuse is the cosine ratio. So that's what I'm going to set up. I'll set up cosine of 37 equals my adjacent side, B, over the hypotenuse, 8. And then we're just going to solve it. Put it over 1, cross multiply. B equals 8 times cosine of 37. Put this into our calculator. 8 times cosine of 37. And we get 6.389. I guess 6.39. And there we go. That's the lesson.